Hey, hello everyone. We're at day 4 of Open Ed 2024. Excited in order to continue this series of presentations we've been giving throughout this week. This presentation is going to be focusing on the ADAPT homework system and specifically how to build learning trees and how to implement learning trees. Uh, and and such. So follows up on previous conversations that we had with ADAPT. If you're unfamiliar with the ADAPT infrastructure, I encourage you to review those videos before jumping into what we're showing today. However, nothing stops you from being able to do so and such. So just as a reminder, the ADAPT homework system is one component of the LibreVerse. The LibreVerse is an ecosystem of multiple technologies in order to advance the goal of being able to to displace the commercial publisher from the classroom. And that means displacing the publisher producing textbooks, displacing them from generating homework system, which is actually more lucrative than textbooks these days, and also being able to displace them from distributing ancillary materials, whether they happen to be question banks or they happen to be PowerPoint presentations or other ancillary materials that you may want to distribute out there. So the ADAPT homework system is a system that was constructed via support from predominantly the state of California and the California Education Learning Lab, which we're very fortunate in order to have that funding. And also we had some funding from the initial inaugural award of the OTP, the Open Textbook Pilot Award from the U.S. Department of Education back in 2018, that has gone a long way in order to be able to facilitate the state of affairs for the LibreTexts project as a whole. So again, the goal here that we have is to focus on learning trees. Now, before talking about learning trees, I want to emphasize what the goal of learning trees are. So in ADAPT, we can present two interfaces for students in order to two mechanisms for students in order to use questions. So one is traditional. So right now I'm going to switch to my general chemistry course. I'm going to avoid pulling up anything that's going to be a conflict of FERPA, but this is the active course that I'm using right now. And I could pull in one of these one of these assignments. And the idea behind a traditional presentation is we have a course has an assignment has a series of questions. In this case here, 2 questions that are out there. I can click on these questions and take a look at them, evaluate them. I could even look at the performance of my class here where most of the students get this question correct, which is perfectly fine because the goal of this question is not necessarily to test them, it's to make sure that the juices are always flowing during the class as part of the pedagogy that I have right here. This is an auto-graded question and such. So anyways, that right there is the traditional way in which we serve questions. The adaptive way is sort of similar, but it has additional layers of complexity associated with it. So in that case there, I have an assignment right here, and this assignment is a learning tree assignment, which is separate from a normal assignment that has the individual questions. So the idea is instead of having a course assignment question, we have course assignment trees. Now, the trees themselves consist of multiple questions and multiple layers of organization behind it, which adds a bit more complexity behind it, but the overall topical view is relatively straightforward, where students get a tree instead of a question. Now, let's look at one of these trees. I'm going to grab this tree right here, identifying significant figures. This is a tree that was created at Cal State University San Bernardino by the team that was on the initial California Education Learning Lab. And the idea behind a tree is essentially you have a root question at the top. That's the question that students get. Ideally, that question is some level of complexity that requires mastering multiple skills in order to be able to be competent in that question. In this thing here, it basically asks this question, but it asks it in 5 different ways. So the 5 different aspects that are associated to master this question. If I get this wrong as a student, I have the ability to go into the learning tree to get remediation, to get assistance in order to update that question. Let me phrase that, assistance in order for me to learn the skills that I need in order to be proficient at this question. And so the idea behind here is that for a good student, let me phrase that, a student that is able to answer this question without any issue, they don't need to know about all the things behind it, which act as a virtual tutor, because they don't need the tutor. Uh, but for the students that need the tutor, they have the opportunity in order to go into the learning trees in order to be able to help advance them. We don't force them typically in order to do that. We just tell them that they have the opportunity in order to go into to get a do-over, that they can then come back and do this question again if they happen to have gotten it wrong. So that's the carrot that we use. We don't use a stick in terms of being able to use these learning trees. So let's just look at what these learning trees look like. So this is a learning tree that was constructed for there. It has at the top a root assessment. So if I click on the node here, it brings up that same question that I just showed you before. So what I showed you before was the question natively, how the student would actually access it. And this shows it in the graphical description of things. So this is the same question that comes in. It has to be auto-graded. And then we have a series of nodes. Each node constitutes part of the tree. And the idea is that this thing, if you were to flip it upside down, it would look like a tree growing up, which has the opportunity for students in order to engage in different ways, depending upon what they're interested in doing and how they can evolve. The key point behind the learning tree is it operates like a choose your own adventure story, such that we don't tell students what they're supposed to learn or supposed to study. We give them the opportunity in order to look at different skills and to learn what those skills are or get a refresher of those skills in order to get the ability to do over and come back up and get this question again. Again, the carrot that I talked about before. So in other words, this is more like a choose your own adventure story than like a black box recommender engine that spoon feeds what students are supposed to address at different points. The benefit off of here, besides improving the engagement between the students and the material, is that it helps to develop things like metacognition. So students will earn a do-over up here if they actually evolve or move through every tree from the top, every node that is, from the top to the bottom. The things that are red are exposition. So they're meant to give you some guidance. This provides a contextual overview of the tree. This provides some context for the specific for understanding, in this case here, significant figures of what significant figures are. This one here provides that context or that exposition now instead of text, but as a video, which may be useful to certain students. We can also provide other components like visualizations, simulations, things that would be fall into the idea of guided inquiry. Whatever the approach that you want to do, you can provide this here for students in order to access. So in this case here, if they go through here, they can identify the skills that they feel that they need in order to master, in order to come back up here and master that question. It's not in their interest, in order to look at a skill where each branch here focuses on a specific skill that they've already mastered, because they're not going to be able to learn how to do this question better by looking at something they've already done. So this intrinsically starts to get the students to look at the questions, or more specifically, to look at the branches and the skills that advances their understanding. And that's where the metacognition development is significantly improved than a spoon-fed approach for doing stuff. The approach that I really like about, or the aspect I really like about learning trees, is the engagement aspect. So this provides an opportunity for students to express agency. They have some buy-in into their educational experience. They're able to interact with it, and increasing engagement almost invariably increases learning. But it certainly brings them closer to the resources and happier about being able to be engaged with the resources, because they have, again, agency in a time when a lack of agency is oftentimes a point of complaint that's out there. So that's the general overview behind the learning trees. To construct a learning tree, you need to be able to identify a question that typically revolves multiple skills in order to master. And at that point, you have to identify those skills, identify the exposition that you may want to give for those skills, and an assessment that's at the end of that branch in order to test whether students got that skill right. Now, I will mention here that this is just one topology for this approach. We can envision other topologies, other mechanisms for students to engage and interact with the structure. This is the one that we chose that we felt was the best, but I can envision other people doing different structures off of here. We have the ability, well, that's largely the gist of the learning tree and how it functions. Is that clear to everybody? I'm not sure if I explained that very well. Learning trees can be a little bit more complex than just assigning a simple question that goes to people. Roy's hands up. Um, Lily, I think, and Lee has a question.
Yes, so the concept of learning trees, is it tied to, can we do it per chapter, or we do it per course or midterm? What is the level of
A learning tree is at its superficial level to take the place of a question. That's all. So if you have an assignment of 5 questions, you can substitute that as an assignment of 5 learning trees.
Mm.
So if you, depends on how many assignment or how many questions that you feel that the students should have. So if you give, for example, a standard homework assignment has 10 questions, you can make 10 learning trees available for students off of it. Now, learning trees are well suited for that they give real-time feedback to students, so they're more engaging. But because they're connected to the root question, they don't get the answer correct, because if they did, then they wouldn't go into the learning trees. It has a little bit of a summative nature, not just a formative nature for them. So it provides a mechanism that they know they need to answer that question correct. If they fail off that question, they can go in here in order to get information. You can think of it as a massive hinting infrastructure, such that they can come back and answer that question again. In fact, that's one really good way in order to say that it's a hinting infrastructure for students. I've never really thought about it within that perspective, but that's actually a fair perspective.
So would you say this is a good, is it appropriate for me to use, like for midterm, right, where we want to test against certain learning income, learning outcome, that we want to know that they actually achieve that learning outcome?
Well, in ADAPT, each question can be aligned to a framework of learning objectives or learning outcomes or skills, whichever one. And we've uploaded 10 to 15 frameworks right now. The issue is that you need to align your question to the framework, which may be easy or may be hard depending upon how many questions you have and the complexity of your framework and such like that. And I have a team of people or students, team of 2, that are focusing on augmenting that and applying that at least to general chemistry in order to move forward. But I have an interest in order to pursue basically everything out there. So from that, irrespective of learning trees, you can come in and you can say, this student did this question right, and this question deals with this learning objective. So therefore, that student has demonstrated some competency for that learning objective. And then you can do the statistics off of that. And we'll release that sort of dashboard for ADAPT this summer.
Okay.
We had to go back and revamp it because of technology issues and things like that for the initial dashboards that we have. But that right there, this one here doesn't address that. But frameworks, the frameworks that you use here does give you the ability in order to get a better idea about whether the students have demonstrated more complex integration of different skills together, right? Because in order, the idea is this question up here shouldn't be a simple true false question. That's not a really good root question for a tree. It needs to have a question that involves multiple components to it that they need to master and bring together into I won't call it synthesis, but a more constructive manner. So the synergy is all right. And that right there can be a more awkward thing in order to identify a functional use of a skill beyond just a simple question to address that skill. So that's what we have here, where these are meant to address specific questions. Like, we're asking about significant figures. Here we need to ask them, do you know significant figures? Before we can actually start going into, can you talk about what is significant in a number, just to use these things. This is still a relatively simple learning tree, but there are lots of other more complex learning trees that expand off of here. For example, in my class right now, I'm going into acid-base chemistry, and they need to have and demonstrate 5 to 7 different skills to answer these questions, understanding what pH is, understanding what uh, thermodynamics under standard conditions, what standard conditions are, non-standard conditions, equilibrium, and they bring together. And I really like these complex questions because they demonstrate synergy of these things off of here. But we have the ability. So one of the issues that we have here in um, actually across the board in sciences is that many students are not mastering certain concepts that they used to master before in math. For example, logarithms and exponents, which is a bane to many people's existence nowadays. Students come in and they don't understand basic logarithm and exponent properties. If they don't understand that, some concepts like pH are based off of that, and they're not useful. So in other words, I don't have to rely on branches that focus on a specific field, right? I can come out and say, look, here's these branches are chemistry, but these ones are math. If you think that you need proficiency in math, then go through these branches in order to understand it, in order to be able to do it. Again, the point is to act as a virtual tutor, but it's a virtual tutor that the students are engaged in activating with, not actually sitting there in order to be able to provide it. That's ultimately what AI tutors are meant in order to do. And if you in several of our presentations this week, I talked about our AI push that we're doing in combination with our portfolio. If you didn't catch that, I can certainly discuss it in more detail, or you can take a look at our YouTube channel. And we had a whole hour focusing on how we're advancing or planning on using AI with our infrastructure. So hopefully
Thank
that,
you. No,
yeah,
thank you. That's very helpful.
yeah. I'm very excited about learning trees. Our initial review of learning trees shows that it does exactly what we want it to do. Students come in, they fail the root question, they spend time in the tree, they come back out and they're successful with it. And that gives a pre-post study, which essentially means that we're able to track not just performance, but true learning, because you have an initial and a final and say, yes, the student learned from the learning tree. And it turns out that's actually identifying learning, if you're not familiar with it, is really quite a pain in the rear. It's actually not as easy as possible in order to say, yes, you have indeed taught students, or that they learned something from that, even though, yes, of course they do. But okay, so that's the basic issue behind these things. I don't want to talk about the analytics and how we're able to track how students move on the trajectories, or how we're trying to analyze the trajectories. That is a topic of a different conversation. And to be honest, we're still trying to figure out those analytics and what's useful from those analytics. So the point that we want to have right now is how to construct a tree and how to well, largely how to construct a tree. Using them is just the same as using a single question that's out there. So um, let's take a look at trees. I'm going to go under dashboard, and I have the ability to browse learning trees. And this gives me the ability to peruse all the learning trees that we have. I'm going to expand this thing out. So we have 900 learning trees. The vast majority of them are for general chemistry topics, although we have some people who've made derivations of them right here. Some are working on some organic chemistry questions. Part of our deliverables to the state of California is to make 500 learning trees per year. And right now we are at 50. So I need to make a lot more learning trees in the near future. So anyone who's interested in building learning trees, please talk to me because I have resources in order to facilitate the construction of learning trees, as long as they're focused on STEM or STEM-like fields. So in this case here, I could take a look at these questions. I take a look at these trees. This is this is an example of the tree. It's a graphical description of things. I don't have the ability to edit this tree because I don't own this tree. I can only edit trees that I own, just like I can only edit questions that I own. Now, the issue that we have here is that each one of these holes here, each one of these blocks represents a node. And a node can either be a question or an exposition. The question is in blue and the exposition is in red. Questions are auto-grade questions. So this was the open-ended question dealing what is the mass of a lithium block. This is just a simple, actually this involves several simple calculations in order to be able to implement, and I could submit and make it work. If I get that wrong, we like to give a specific node, specific exposition node that is in this format that we provide that allows people, that gives a templated presentation to the students in order to guide them in terms of using the tree. For example, in this case here, it's saying, you didn't answer this question right. You need these 3 concepts in order to be able to master, or at least be proficient at handling that question up there. So these are 3 concepts you need to master. We provide you with 3 branches to address these concepts. We may involve multiple branches. For example, one branch may involve teaching by video, one branch may be teaching via text, or teaching with example, or even a scaffold-based self-learning approach via exercises. The intent is to provide a flexible range of options available for the students in order to be able to learn from, and they get to guide themselves in the way that they want to go about doing so. So in this case here, branch 1 deals with the conversion of atoms to mass, and we provide text just as the exposition. Branch 2 is the same topic, but that's providing video. And 3 is a procedure to convert from atoms to mass, which is just straightforward conversion factors. And then a little bit of affirmation to keep on going, and then that's it. This is useful because it provides context to the students. If students don't have context, it's difficult for them to exercise agency, or at least believe that their agency matters, because it's not informed in terms of being able to move forward. The second benefit off of this is it provides a context around the connectivity map, because essentially this node, or this tree here, represents a connectivity map of concepts to master this specific question. Now, I've been exposed to connectivity maps in chemistry for a long time. Many of you have also been probably exposed in your own fields for them. I've had a hard time trying to figure out how to teach with connectivity maps, how to use them as a constructive infrastructure or a constructive mechanism for students to engage with and learn from. Now, I'm not saying it's not possible. I'm just saying I had a problem doing so. In this case here, we're essentially taking that connectivity map and giving a little snippet of the connectivity map. I said, for this question, you need to master this, 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 and this. And then they understand why these things are important in order to understand these questions. And it's this dissection and getting into the details of the question to understand how it works provides a more than just a topical level of understanding what that question means, and they can dig into it and have a greater understanding once it's all said and done. And that's one of the benefits that, again, learning trees provide. The issues with learning trees and learning tree construction is that it takes a bit of effort to create. You're not creating one question. In this case here, you're creating 7 different questions and or exposition texts. So it takes a bit of time in order to be able to build. And invariably, you're going to go in and start to manipulate it and expand on it as you see fit. And I encourage you, in order to remember that you don't need to be perfect with your learning trees to begin with. You just need to be able to make something that you're able to work off of and such. So let me continue moving through here. I mentioned this strategy map, this initial exposition mode. Then make a decision to go down to to any of the branches that we have here. Let's say they decide to go down this branch, and this branch is largely exposition. And this is actually very sparse exposition, telling people, here's a node, here's a little bit of an aspect, giving them a link, in this case here, to the OpenStax version of this book. I would go in there and change it to the LibreTexts version of the book, because we don't like to have external links from the LibreTexts project. And it just gives you a little bit of information. To convert from mass to moles, you do this. To convert from moles to mass, you do this. Now, this is not much exposition. Let me phrase it. This doesn't have much text in the exposition. Oftentimes, we have text in the exposition available. And then after that exposition, and that exposition could be multiple pages, multiple nodes. You don't have to have much modes. You can have 2 or 3 nodes that you said, well, look, this is a complicated issue. I want to talk about the first topic, the second topic, and the third topic. And now I'm giving you a question to evaluate whether you understood that. And if that happens to be the case, I click on this and I get the right answer, which I may not get the right answer because I didn't actually dissect it. And actually, this should be expanded off of here. I should be taking a look at that in a moment. let me copy this and edit this after the fact. So the same thing here. Here's the training. I can watch through this video. If I like the video, hopefully I'll learn from the video and then demonstrate that I have some proficiency from learning from the videos. And now I have the ability as a student to get the do-over. I come back up and I do the problem off of it. This right here is dealing with a question that is largely a simple question as a refresh. It's not entirely focused around a specific branch or specific node. The idea is some students will learn best from problems and not from expositions off of there. So hold on one second, please. Sorry about that. The issues of sitting in my office with students coming by here. So that's the basic template of things. Let's go into organizing these. So when you come in, you want to have a game plan. The game plan is not terribly dissimilar from the game plan that people have when they construct remixes from books. In that sense, we create a remixing map that tells you what pages are organized in what structure as you start to remix and generate your book. And I went over that in a remixing video that's on our YouTube channel from this week. In this case here, you're coming in and you have to ask yourself, what question do I want as the root question? What concepts do I want that question to be able to evaluate? And then once you identify the concepts or the learning objectives or learning outcomes or specific skills that's connected to that, identify what expositions you want for those specific skills. And that may require individuals to write things in or to capitalize on the vast corpus of content that we have in our libraries. And this, for example, is not a terribly great learning tree. This is a very linear learning tree too. So, and then identify the question that's actually involved in this. And this is actually distorted. This should be changed a little bit. So this is text that hasn't been converted to auto grade. So we need to go through that. Sorry to show you some trees that haven't been fully fleshed out as auto graded as necessary in order to make it work. So the upshot, what I was trying to say there was essentially you need to have some organization about what you want for your learning tree to address. And that right there is typically requires some level of subject mastery for what we're doing, which is what we all expect that faculty are able to do. If you ask students to be able to construct a learning tree, some students are actually able to do it, but many students will have a problem not doing it. And we use students quite productively in terms of building many aspects of the learning tree, many aspects of the LibreVerse. And this just basically is one aspect that needs to be handled in a very controlled fashion if you want to be able to do it, because it requires a bit more mastery of the subject matter in order to do so. So now that I laid that out of the way, let's talk about actually building a learning tree. So I'm going to open up a new tablet and I'm going to go to my learning trees. So I was browsing through existing learning trees. Now I'm just going to go to my learning trees. In this case here, I have 3 learning trees that are in place here. I have no memory of making these things. So it looks like I have created something right here. But let's create a new learning tree. For those of you that have, actually, I should ask you, are you guys following along with an account on here, or you just want to actually watch it on a video and I shouldn't be asking you in order to do something on your side, like it were in a real workshop?
I'm just watching you right
You're
now.
just watching? Anybody else? Okay. Okay, so now that I know you guys are following on video, I'm not going to rely on you or delay things as you start to move along. And let's make a new learning tree. So I'm going to, on here, click a new learning tree. I have the ability to clone a learning tree, which is to take someone else's learning tree and copy it as my own that I can start to modify. I want to just do a new learning tree right now. And it asks for a few details like title. This is my tree. A public description, I like trees. A private note that this is what students don't see. In this case here, I hate trees. And I can decide if it's public or private. I'm going to make it not private. Sorry, not public, because there's no reason people need to see what I've created. And now I've created a learning tree. I created nothing other than an entry for a learning tree, but I'm going to be adding learning trees off to here. So the idea that we have here is the fact that we want to start breaking the concept of the hierarchy I said before. So I said that we had course, we have assignment, and then we have questions. So in this case here is course, assignment, we have trees, but the trees themselves consist of nodes and then questions inside the nodes. So it has another layer or two layers of complexity off of here. We start to organize nodes, and then we put into nodes questions or expositions. So let me show you about how we go about doing that. So the first thing is, if I know the code of the question that I want to be the root question, I could paste it in here directly. Alternatively, I can just add a node and it just makes an empty node right there, which is perfectly fine in order to do. So in this case here, I could do something like add nodes and build a structure that looks like this, which is a conventional structure that we have. So this is what a conventional learning tree looks like. A root question, a strategy map, expositions for different skills, and then some mastery of those skills. But of course, I have the ability in order to change it like this and make multiple expositions or multiple tests. It's up to me depending upon if that skill requires a bit more than just two things in order to be able to address. And many skills can't be summarized in a single exposition. Now, what I've created here is an empty shell of nodes that have no questions in them and have no exposition in them. They just are empty. If I double click on them, I have the ability in order to, I'm not sure where that number comes from, but I have the ability in order to paste in the adapt ID number of the question I care about. So this gets back into having an organization or a plan. So this is oftentimes well suited in order to go to a piece of paper and write down this node structure and then start to go through and say, what do I want this to be? Because it's easy to make poor learning trees. Again, I want to pick a question that has a lot of complexity associated with that. So I'm going to go through the question bank and I'm going to pick a question that is hard. So for example, I'm going to grab something way out here. Let me see here. This is a question. I'm looking for something that's complicated. Let's say I took this question, and this question right here has an equilibrium. This is the temperature dependence of equilibrium constant. I need the ID number. Here's the ID number for that question. Following what we had discussed previously, I can come into here and paste that ID number right there. I'm going to refresh the node. And now if I save it, I've inserted that question into that node block. Again, remember, I'm talking about now courses, assignments, trees, nodes, and then questions go into the nodes. And the nodes operate as a topology for the contents here. You guys cool with me so far? Any questions or concerns? Okay, so I can come in here and I can, let me see what so there's a good, so it wants, okay, equilibrium uses, this requires a definition. Oh, I didn't actually read this question carefully. Okay, so this is just basically applying the the law of mass action. And it's not overly complicated off here, but it does require understanding activity is equal to 1 and what the law of mass action is. So in this case here, I have this empty node and I need to put in a question connecting to it. I add questions that are pre-existing into the learning trees. The learning trees are not meant in order to facilitate the construction of questions or the construction of expositions. The learning tree interface is meant only for being able to organize existing nodes, let me phrase it, existing questions and expositions into a node structure. That doesn't mean I can't come in and edit the node source if I have editing rights, and it will pull up the editing question associated with it. This is the question that I showed before. Those of you that have seen Adapt before have already seen this interface for editing a question. I'm going to exit the node. This one here requires a exposition. So I'm going to go in and I need to build a question, something with exposition. So I'm going to go into my question area. It's pulling something from the database. In this case here, I can then create a new question. And then it has this option up here. This is question, and exposition, and report. Report is not important for what we're dealing with here. Exposition is what important. So for those of you that have been exposed to Adapt before and you didn't do learning trees, I basically told you to ignore that entry. Now, if you click on exposition, you are making an entry in the database that is not a question, but is an exposition. And it's stored in the same database as our questions. So in this case here, I can say exposition. It's actually strat EG map of whatever of tree 1, tree 20. I have a tree number here. I thought I had a tree number. It says a tree number somewhere, but whatever. I say tree 221. In this case here, this is how you create questions. I didn't want to go into creating questions too much. I just want to be able to introduce the fact that instead of all the stuff associated with question, you just have content here that you can write down and basically say, this is the strategy map for this question. Do 3 skills. And I'm saving this. And this is saved just like it were a normal question that would use convention. However, it is an exposition node, which has no utility outside of learning trees. So now if I come in here, and I forgot what the learning tree, what the ID number is of that exposition, which is this number here, 216532. And I can just paste it here and refresh it. And now I've just added that exposition into that node. And it's just text right there, and I can save it. So if it has no exposition or question base to it, it's just gray. It says empty learning tree. As soon as you add something into it, if it turns blue, it's a question. If it's red, it's exposition, meaning that it's not meant for to test students. It's meant to instruct students on something. And that's essentially what you do here is you create the expositions and you identify the questions to test the expositions or test what the expositions are meant to address as you start to flush through these things. I don't want to go about doing this thing because I don't have an organized approach for what I want the specific question to address, but it is beneficial in order to go through existing courses with existing questions and say, here, this is a question. How many skills do you need in order to master this question? Make a tree and then provide the tree to students instead of the original question, such that the students that need the help can go into the trees in order to be able to do it. The students that don't need the help don't even know that the trees are there, and it's just like it's a normal question. So there's lots of evidence out there that these sort of approaches are superior to just a single question issue. The issue is going through and creating all the the infrastructure for making these trees work effectively, and that's out there. And then we collect data all the time on how students are interacting with the trees in order to be able to share and say this tree is useful and this tree here does not appear to be as useful. In other words, students are not demonstrating learning from going into the trees when they have the chance in order to do the root question again. That's the upshot. If we This is a really good topic in order to address as a sprint where individuals come together. They spend an hour and a half going through the sort of things that I talked about, learning off of it, and then just spending the rest of the day building learning tree after learning tree and moving forward off of that. And that's one mechanism that we are pursuing in terms of really advancing the construction of learning trees into multiple fields. We're very happy with that sort of approach. We're very happy with this infrastructure in place for things. So I will show you at the end, which is right now, how students use learning trees. Before I do so, I just want to check to see that this makes sense for people on how to construct learning trees and how to move forward with how we've done it. I can go over it again if that's a concern or a question someone may have. Yes, Lee.
So how do I know to find some learning trees that's similar to what I need? Is it strictly by the title or there's some categorization that help me?
That's a good question. We need to improve the classifications of these learning trees and make it easier for people in order to access or to identify that. Right now, the learning trees are based on titles that you can use in order to peruse. Like I said, there are only 195 public learning trees out there. So finding whether you have an existing learning tree to work off of is relatively easy now, but it will be expanded so you can go through and identify this is my learning outcome. What trees address my learning outcome? We don't have that in place, but we will soon. Yeah. So just as a infrastructure under frameworks for your dashboard shows you the learning objectives that we have. For example, here's the calculus OpenStax questions. We've been harvesting the OpenStax learning objectives because OpenStax is so popular. It's out there. It's not necessarily that these are particularly better than any other frameworks. In fact, they're oftentimes haven't demonstrated that, but that's a different story. So in this case here, you can say, I want this question to have this learning objective. And then when you do a search, you can come through it and being able to identify that and move
Yeah,
forward from there. So
that would be very, very helpful because I want to build learning trees for the database section.
mhm.
And that has a lot of like mini lessons in there. Yeah, you have to learn how fields is before you can, and then the data definition. So all
Yeah,
these are
yeah,
snippets, and it just seemed like such a perfect example, at least right now in my mind.
it is.
You're
So
learning trees for
yeah,
that, but it could be, it doesn't have to be just from my field, right? Because learning how to the concept of key, that is like anybody had doing anything to do with data or table would have to learn about those things or tables or
yeah.
things like that.
So one of the things that we wanted to do was something a little bit more nuanced, but we think it's important, and that's to identify branches. So we identify a branch with a specific learning objective. So when you do a search through a learning objective or through the trees, you can say this question, this tree here has a branch dealing with this specific learning objective. And then you can say, well, you want that learning objective in your tree. You can just come in and copy that branch into your tree, but that adds a little bit more complexity in the way the tree is structured rather than the simple dragging and drop. Or if I type the ID here, it would introduce the node directly that I can drag into it. And it's already somewhat unconventional. Most people are not comfortable building trees and envisioning things like that. So as I start introducing a more complex aspect to it, I think it could be daunting. So I'm taking a step back behind here before we pursue that and get people comfortable with the idea of a graphical description of how things are organized and identifying them and making them set up like that. So each of these questions, which is not shown up here, we have a, where are we? We have a, well, right now they're called private notes. They used to be called branch notes. I should
Mhm.
probably take a look here at one of the other ones. Uh, it's meant in order to give you information about the learning objectives branches, but we will
Mhm.
hook it up to the framework so that you can identify this learning, this branch here deals with this learning objective.
I see. Okay.
Right here, here's a no description. I think we may have changed the title to no
Mm,
description that connects to it. So as it grows, it becomes easier in order to be able to do this. This is akin to my argument of the LibreText as building a bigger box of Legos. The
mhm,
bigger the box of Legos is, the easier it is for you to be able to build what you want to do.
mhm.
The issues are people like you that are coming in and starting from scratch, that you have to go through and slowly go about doing this thing.
Yeah.
But like I mentioned to you, if you get several of your colleagues together and having a sprint where you can get down and say, okay, this is how we go about doing it. Let's build this and let's start going through and building these things, or
Mm,
even just slowly writing these things down on a piece of paper that says, this is the ID number here with this ID number and all. And then you come in and you start to build it together. Both of them are equally useful in order to be able to advance and move forward off of that. I'm very excited about this because, like I said, there's lots of evidence that shows that this works better than having a single question. Uh, because it essentially has a question with a little built-in mini tutor. And the term virtual tutor has been thrown around a lot, but that's the ultimate goal behind many of these adaptive learning infrastructures. This just happens to be a very simple adaptive learning infrastructure instead of an AI-based machine
yeah.
algorithm, da, da, da. But it does a pretty good job.
I love this. I mean, I've been wanting to do this because it's replaced the whole assignment I have that takes a lot of time grading to learn where they actually learn how to create a database, even a
Yeah,
simple and stupid database.
yeah.
So this is, I said, it answer all my needs, right? The engagement for student and don't make them feel so scary.
Yeah, yeah, and you get good information off of here, and you can identify
Okay.
when you want to do intervention or if there's something missing from topics or things like that. It's there's really a lot of potential off of here.
Okay.
However, Roy mentioned something in the chat that he built a robust learning tree and said it's very unwieldy. I presume you're saying that you have a whole slew of different branches connected to your learning tree, or you're talking about something else.
I'm talking about a just a Excel spreadsheet of
Um,
just a basic set of skills that students learn through the math sequence.
mhm.
And I mean, it was really robust, hard to categorize. And I was just thinking of that in terms of learning trees. That is really going to be a hard categorization. Aligning it with a textbook or textbook, traditional textbook chapters and sections might be the best because within the math community, we textbooks all are kind of the same as
It's
far
somewhat
as their
similar, yeah,
structure.
right.
Yeah.
I mean, you have your outliers, but yeah.
Yeah.
But yeah, I mean, so one of the easier things to do is to go through, for example, the if you're aligning, if you have your questions already aligned to OpenStax. So let's say you built them in, you did yours in my but we brought your questions in. So I can come in and I could say, let's say I want to, I'm going to go and look through the the comments. Actually, I didn't. Actually, I did put your stuff in the comments, I think. No, I didn't. Your stuff is still in your shell. So what I'm trying to do is I'm pulling up his courses that he has already aligned to his textbook. And so in this case, here you take the differentialization differentiation problem, and you can say, well, here is the question that you have, which is just hyperbolic. You're really abusing your students, aren't you? Hyperbolic natural
They
log over
need
9. Yeah.
that for differential.
Yeah. Yeah. Well, just the idea you're bringing hyperbolic functions is pretty impressive. But you can come in and say, okay, well, here's this question. What are the skills that you need in order to be able to master that question? And now build a tree behind that root question. So you've already have it aligned to what you want. You just need to know what skills you feel that they need to master in order to be able to do this this question. So I digress. Math is really quite beautiful in order to do these things because you have a really good structure to work off of. You understand how things are built off of it. other things like chemistry and such, yes, we do have frameworks in order to work off of and connectivity maps and things like that, but I think it's a little bit less obvious than how math is put in place in order to be able to do that. So anyways, we've actually exceeded our time, so I didn't have a chance in order to show you what a student looks like when they access this question, but it's relatively straightforward. They take their question. If they decide to enter the node, they then they show the trees, and they're able to interact with the trees in the same way that we interacted with here, and they have the graphical interface that's off of here. We do have in place, or it's about to be in place, an infrastructure in order to provide the trees in an accessible manner, so that students that require screen readers are able to come in order to be able to see how the tree is organized, and it doesn't rely on just visualization, although visualization certainly is very useful in order to be able to get everything as a whole. So I digress. Um, I certainly love talking about trees. I think they're very exciting in order to do. I think there's lots of potential off of here, and we're very interested in order to really expand learning trees capabilities out there. We are going to be pursuing other types of learning analytics with things, but for now, this is a more active infrastructures, but more active adaptive learning capabilities than just learning trees. But this is what we have right now, and this does a great job in order to be able to advance what we want to do. So with that, I'm going